Number 67. All right, so now we're going to see this circle. We're going to look at all the segments that have intersected it, and we're going to find the length of different ones of them. So we know it has a diameter of 20. Now, I don't like marking diameters on circles, but if something has a diameter of 20, that tells me that the radius has to be half, which is just 10. So now I know that the radii are 10, and I can actually mark all of the radii. OR is a radius as well, and so that will also be 10, and I might need to know that. UT is 16, so this entire segment right here is 16. Let me highlight that. This segment is 16 units long, and that's great, and I'm very happy to know that, because now that I know that UT is actually perpendicular to RS, UT is perpendicular to RS, this angle right here is a 90-degree angle, I know that RS, whenever a radius is perpendicular to a chord, it bisects that chord. So these parts are equal. So even though, yes, the whole thing is 16, that means each part of it is 18. It's 8, and that's much more useful to write down the diagram. Last but not least, I know that SM is 24. From here out to here is 24 units long. SM is a tangent, or part of a tangent line, and that might be useful too. Okay, so first of all, we want to know, what is the length of OW? So OW is this little part right here, and that's the part we're going to try and find. Okay, it's not written on here, but I'm actually going to complete this triangle right here by drawing an OU. An OU is a radius, which means that it is 10, like all the other radii. And now that I know that, I can see that there's a little right triangle that exists there. And so if I take x squared plus 8 squared, I will get 10 squared because of the Pythagorean theorem. X squared doesn't change. 8 squared is 64, and that equals 100. If I subtract 64 from both sides, I end up that x squared equals 36, which tells me that x is 6. And since I called x OW, that means OW is 6. All right, what is the length of LM? This is part B. We need to find LM, and LM is this little part right here. Now, instead of trying to find LM directly, I'm going to try to find the length of OM, and then I'm going to subtract 10 from that, since OL is 10, and that will help me find LM. Okay, so I know that a tangent line, and this right here, they're perpendicular, because it tells me right here that RS and SM are perpendicular. So we have ourselves another Pythagorean theorem where 10 squared plus 24 squared equals, and I'm going to give this a name, I'm going to call it y squared. 10 squared is 100. 24 squared is 576. 576. If I add 100 to 576, I get 676. And so the square root of 676 is 26. Okay, so this entire segment right here is 26. That wasn't what I was asked to find, though. I was asked to find LM, LM just being this part right here. And so if the whole thing's 26 and this part inside the circle is 10, that means LM is actually equal to 16.